Okay, welcome to our second lecture in Biology 160, Introduction to Anatomy and Physiology. In today's lecture, we're going to be talking about chemistry. You may wonder why, if you're taking a biology course, specifically anatomy and physiology course, why are we going to take the time to talk about chemistry? Well, chemistry and biology, or chemistry and anatomy and physiology, are interlinked. You can't understand one well without understanding the other. A lot of people don't realize that, but to really understand what's going on in anatomy and physiology, you have to understand what's happening in chemistry. There will be a number of sections in this chapter where we're going to talk about ions, we're going to talk about transport, we're going to talk about functions and physiology in the body. It's all going to come back to this chemistry. Sadly, I think a lot of people have a bad image of chemistry. They've had a bad experience with chemistry in the past. Hopefully today, as we talk, you'll be able to get the basic rules that you'll need to understand anatomy and physiology a little bit better, and hopefully you'll get to the point where you enjoy chemistry as well. If you take a minute and think about it, you'll realize that chemistry is all around us. Most of the time we don't think about it, but even water, that you take a drink of water, you go to the faucet, you turn on the faucet, you get a glass of water, you drink that. Water is chemistry, the chemical makeup of water, and we're going to talk about that today. Every time you eat some food, there's chemistry happening. Your body's digesting, the breaking down of molecules, the building up of molecules. Without chemistry, we wouldn't be alive. Luckily, we don't have to think about it for most of it to happen, but in order to understand anatomy and physiology, we need to understand chemistry. So with that little bit of intro, let's get moving here. So first of all, we're going to talk, I just want to mention briefly this idea of matter and energy. Matter is anything that occupies space and has mass. So we're all built of matter. When we talk about the different elements, they are matter. So everything around you is made up of matter. Your body is made up of matter. Both living things and non-living things are composed of matter. There's also this idea of energy, and matter and energy are interconnected. But energy is just the ability to do work. It's not necessarily something that has mass. But energy comes in a few different forms. You've probably heard of before, or hopefully you've heard of before, this idea of kinetic energy and potential energy. These are the two main types of energy, kinetic energy. Kinetic energy is the energy of motion, the energy of movement. Potential energy, as it sounds like, it's the energy of position. So something has potential energy if it's kind of like a stored energy. And a good way to think about this is if you have, for example, let's say you have a hill, and at the top of this hill you have a ball. At this point, when the ball is sitting at the top of the hill, that ball has potential energy. It has potential energy because of where it's located. Has potential energy because it has the ability, or has the potential, to roll down that hill. Right now, so at this point, the potential energy, there's lots of potential energy, no kinetic energy. But if this ball starts to roll down the hill, that potential energy has now been converted into kinetic energy. So potential energy and kinetic energy can be changed from one form to the other. When the ball has potential energy, it doesn't have kinetic energy. When it starts to roll, now that potential energy is turning to kinetic energy. By the time that ball gets down to the bottom, it's no longer moving. The kinetic energy is gone. Energy also comes in these forms here: chemical, electrical, mechanical, and radiant. Chemical energy can be both kinetic potential, electrical can be kinetic potential. So kinetic energy and potential energy are the two general forms, and then kinetic and potential energy can be the form of these other chemical, electrical, mechanical, and radiant energy. We'll see examples of all these types of energy as we go through through this course in anatomy physiology. For example, chemical energy, we see that in digestion. Electrical energy, we see that in the nervous system. For example, mechanical energy would be the movement of our muscles, and radiant energy is heat that is being produced. So those are the types we have of energy, and that's a little bit about matter. So matter, let's continue on this idea of matter. And we won't really talk much more about energy in this chapter, but we're going to talk a lot more about matter. So matter, again, is anything that has mass, and the elements are made up of matter. Our body is made up of matter, and if you were to take your body and chop it up into the elements, then you'd find that 96% of your body comes from just 4 elements: carbon, oxygen, hydrogen, nitrogen. So we're actually not, when you break it down into this basic composition, we're not really made of that many different things. But then you can take carbon, oxygen, hydrogen, nitrogen and build them into all these different forms, and that's where you get all the different molecules, and we'll talk about that a little bit later. Here's what's called the periodic table of the elements. So matter is made up of these, or elements are what make up matter. In the world, there's about 92 to 98 naturally occurring elements, and they're all listed here. And a lot of them you may be familiar with: hydrogen, helium, lithium, carbon, sure you've heard about, sulfur, chlorine. These are all different elements. What that means is that this is the most, if you take something and break it down to its most pure form, that is what an element is. Not that an element can't be broken down further, but that's the most unique form. So there's 92 of these unique forms of elements in the world. And of these 92, but then there's some man-made ones you can see here, so it goes clear up to 114. Some of these are man-made. But anyway, of these 114 elements, only 4 are really abundant in our body, oxygen being the most. And then there are some other elements that come into play as well. Calcium, of course, is common in our body, but there's only about 1%. Phosphorus and sulfur, those are 2 other ones that are found in all living things. And then we have sodium, electrolytes, chlorine, magnesium, iron, etc. So there's a few other elements that make up that last 4%. The other term here is what's called an atom. An atom is what elements are built of. So carbon, we say there's carbon atoms, there's oxygen atoms. So we're going to look at atoms and what makes an atom an atom. What makes an atom a certain element. So here is the periodic table of the elements. And as you look at these elements that are written here, you'll notice some things about each of the elements. So for example, let's take a look at carbon. That's one we're all familiar with. So carbon is represented by C. So each of the elements has an abbreviation that represents that element. C stands for carbon, N for nitrogen, O for oxygen, etc., etc. Above the abbreviation, we have a number. In this case, carbon, it's 6, and below the abbreviation, we have a number. In case of carbon, it's 12. If we come up here, we'll notice that that top number is called an atomic number. So, for example, helium has atomic number of 2. 6 is the atomic number of carbon. The number below is called the atomic mass number. Helium, for example, has an atomic mass of 4. Carbon has an atomic mass of 12. That's true for each of the elements. You'll notice that they have a number above the atomic number and a number below. That's the atomic mass number. I want to focus on just 3 here for a minute. We have hydrogen. Notice that its atomic number is 1, mass number is 1. Helium has an atomic number of 2 and a mass number of 4. And lithium has an atomic number of 3 and a mass number, when you round up, of 7. So let's look at this slide now. And you'll notice that we have those 3 elements that I just mentioned: hydrogen, helium, and lithium. I'm going to write up the abbreviations as you saw in the periodic table. So hydrogen has a 1 above and a 1 below. Helium is He, atomic number of 2, mass number of 4. And lithium has an atomic number of 3 and a mass number of 7. That's how they looked on the periodic table. So I want you to pause this recording just for, well, as long as it takes you, but I want you to pause this recording and I want you to look at each of these atoms. Oh, wait, before you do that, I want to point out a couple other things I forgot to. We have here some subatomic particles as well. So you'll notice there's protons, neutrons, electrons. These are the building blocks of atoms. Every atom is made up of a certain number of protons, neutrons, electrons. So you can see here, when you look at hydrogen, notice it has 1 proton, 1 electron, and nothing else. Helium has 2 protons, 2 neutrons, 2 electrons, and lithium, etc., etc. The subatomic particles, as I mentioned before in the previous lecture, you can break these atoms down into these subatomic particles. And so what I want you to do when you pause recording, I want you to determine what makes each of these elements that certain element. Or in other words, what makes hydrogen hydrogen? What makes helium helium? What makes lithium lithium, as determined by these subatomic particles? And then also, along the same lines, how do these subatomic particles relate to the numbers around these abbreviations for the element? So go ahead and pause the recording.